Hello everyone. So today we are going to learn on the understanding of amplitude modulation. In this short presentation, we will discuss on the basics of amplitude modulation, variants of AM signal, and some of the applications of amplitude modulation. Before we proceed, let me introduce the group members. My name is Amyza, and these are my teammates, Nur Adila, Nur Anis Maisara, Guat Sichi, and Rasta Lili. Therefore, without further ado, let's get started. What is amplitude modulation? Modulation is the process where the message or modulating signal modulates the carrier to produce transmitted signal or recall modulated signal. This is the general equation of sine wave, and there are three things we can change about it, which is its phase, frequency, and amplitude. Therefore, amplitude modulation is changing the amplitude of carrier signal to convey information. How do we create AM modulated signals? Most often, AM signals are created using a mixer. The inputs are unmodulated carrier and a low frequency modulating signal, and the result is a modulated RF carrier. In time domain, this figure shows the modulating wave, which is the message signal, and this is the mathematical expression for the modulating signal. Next one is the carrier wave, which is a high frequency signal and contains no information. And this is the wave equation for carrier signal. While the last one is the resultant modulated wave. Then the equation of amplitude modulated wave will be: it can be observed that the positive and negative peaks of the carrier wave are interconnected with an imaginary line. These lines helps recreating the exact shape of the modulating signal, and this line is called as an envelope. Envelope has maximum and minimum value. In frequency domain, the information in an AM signal contains of sidebands that appear both above and below the carrier frequency. For instance, if we use 1000 Hz sine wave signal as our modulation source, this modulating signal appears as 2000 in the spectrum, 1000 Hz above and 1000 Hz below the carrier. AM modulation index describes the ratio of the sideband amplitude to the carrier amplitude. In other words, M is a sideband amplitude divided by carrier amplitude. AM modulation depth is the modulation index expressed in percentage. We can compare the modulation depth by using time domain. For a perfect modulation, the value of modulation index should be 1, which implies the percentage of modulation should be 100%. For the case where the modulation index is less than 1, undermodulation occurs and the modulated output would look like the figure, and it is called undermodulated wave. If the value of the modulation index is greater than 1, then the wave will be an overmodulated wave, and overmodulation occurs.
The first kind of amplitude modulation is double sideband full carrier. So let's see some insight about this. Let me fill you first with what double sideband modulation actually means. Double sideband is simply the multiplication of a carrier signal with a message signal. There are two types of double sideband modulation. The first one is double sideband full carrier, and the second one is double sideband suppressed carrier. These are some of the characteristics of double sideband. The first one is the information in the two sidebands is the same. The second one is the bandwidth required is double. The third one, less number of channels in a given frequency range. And the fourth one, easy data construction. So let's jump into our first subtopic for today, double sideband full carrier. Double sideband full carrier is a transmission of a signal which contains two sidebands, symmetrically spaced above and below a carrier signal. As you can see in the orange circle, the position of the carrier signal, and it is sandwiched between two sidebands, which is the upper sideband and the lower sideband. So here are the frequency spectrum and the formula to calculate double sideband full carrier. As you can see in the spectrum, the carrier signal is always situated in the middle of the two double sidebands. So to calculate, the first part of the equation in the circle is for the carrier signal, while the latter is to calculate the double sidebands. Double sideband for carrier is not a mainstream choice these days. Let's figure out why by comparing the advantages and disadvantages. Move along to the advantages. It has a simple demodulation process and it is efficient for long-distance communication. However, it is accompanied by a lot of disadvantages, which are it has high power waste, and the transmission is noisy, it has redundant of data due to double sidebands, and also it demands high channel of bandwidth.
Hi, I'm Sichi, and now I would like to present double sideband suppressed carrier. So what is DSBSC? It's the transmission of a signal in which its carriers are suppressed and sidebands are allowed for transmission, as shown in the graph below, where only the lower sideband and the upper sideband are transmitted. So DSBSC is generated by a mixer which multiplies the message signal with the carrier signal to obtain the modulated signal, and the modulated signal has only half of the amplitude of the message signal. Next is the power and frequency spectrum. The total power of the signal can be obtained by adding the power of both sidebands to obtain E squared n divided by 4R. The frequency spectrum illustrates the amplitude of the components of the signal at its respective frequency, and the bandwidth of the signal is equal to 2 FM. Next is the waveform. Every time the message signal crosses 0, phase reversal happens in the DSBSC waveform. Last but not least is the advantages and disadvantages. The advantages include 100% modulation efficiency, consumes less power due to suppression of carrier, and larger bandwidth. The disadvantages include complex detection process, sometimes difficult to recover the signal at the receiver, and expensive technique when it comes to demodulation of signal.
Hi! Next, we are going to learn about single sideband suppressed carrier SSBSC. Here are some of the points that we will go through one by one. Number 1, overview. Number 2, definition. Number 3, advantages. Number 4, disadvantages. SSB modulation is widely used in the high frequency or shortwave portion of radio spectrum for two-way communication. It is derived from amplitude modulation and SSB modulation that overcomes a number of disadvantages of amplitude modulation. SSB modulation normally used for voice transmission, but technically it can be used for many other applications where two-way radio communication with analog signals required. Next, let's look at the definition of SSBSC. Single sideband suppressed carrier SSBSC system is a process of suppressing one of the sidebands along with the carrier and transmitting a single sideband. Figure shown that the carrier and the lower sideband are suppressed, hence the upper sideband is used for transmission. Similarly, we can suppress the carrier and the upper sideband while transmitting the lower sideband. This SSBSC system, which transmits a single sideband, has high power as the power for both the carrier and the other sideband is utilized in transmitting the single sideband. Now, let's move to the advantages and disadvantages of the SSBSC. Advantages: bandwidth is lesser than AM and DSBSC. Transmission of a greater number of signal is allowed. Transmitted power is safe. High power signal can be transmitted. Less amount of noise is present, and signal fading is less likely to occur. Disadvantages: Number 1, the generation and detection of SSBSC wave is a complex process. Number 2, the quality of the signal gets affected unless the SSB transmitter and receiver have an excellent frequency stability. That's all for the SSBSC. Thank you.
After we have learned the three types of amplitude modulation, here it is the comparison between the three types of them, which is DSBFC, DSBSC, and SSBSC. So the SBFC is a double sideband along with carrier AM, and same goes to the SBSC but without carrier AM, and SSBSC only one sideband without a carrier. Next, for the number of channels in a given frequency, the SBFC has a less number, same goes to the SBSC, while SSBSC have more number of channels in a given frequency. For the SBFC and the SBSC, it have a bandwidth of twice modulating signal, while SSBSC have a bandwidth of a modulating signal. For the power consumption, the SBFC have more power consumption and leads to redundant data, while the SBSC moderately redundant data and SSBSC has less redundant data. For the power transmission efficiency, the SBFC is less and the SBSC is better than the SBFC, while SSBSC has best transmission efficiency. Next, the SBFC have easy reconstruction because it is simple, while the SBSC moderately difficult reconstruction and it is less simple than the SBFC. While for the SSBSC, it is a difficult reconstruction because it is the most complex. Now, let's see the application of the amplitude modulation. Amplitude modulation is used in a variety of applications, even though it is not as widely used as it was in previous years. In its basic format, it can nevertheless still can be found. First, for the personal use, people are using cell phone and walkie-talkie to contact with their friend. For example, during convoy with friends, some people are comfortable using walkie-talkie because walkie-talkies are much faster way to alert a large group at the same time. Next, for the entertainment use is radio broadcasting and analog TV system that is used to transmit color information. Then, for the business purpose, CB radio is used to relay shipment progress or conference call with other branches via telephone or speakerphone. Next, inside the military, for example during the war, they are using undetectable signal to communicate with other soldier or voice command to control the weapon. Next, for the government purpose, for example, police officer keeping a contact with station or relaying the information and location of the suspect during the mission. Now, let's take one of the example application amplitude modulation to see how it works, which is radio broadcasting. Before we go further about this application, let's see the history of it. The first amplitude modulated signal was transmitted in 1901 by a Canadian engineer named Reginald Fessenden. He took a continuous pulse transmission and placed a carbon microphone in the antenna lid. The sound wave impacting on the microphone varied its resistance, and in turn this varied the intensity of the transmission. Although very crude, signals were audible over a distance of a few hundred meters. There was a rasping sound caused by a spark. With the introduction of continuous sine wave signals, transmission improved significantly and AM soon became the standard for voice transmission. Nowadays, amplitude modulation is used for audio broadcasting on the long, medium, and short wave band and for two-way radio communication. So, now let's see how it's works. AM radio uses the electrical image of a sound source to modulate the amplitude of a carrier wave. So, this is the block diagram of the AM radio transmission. It consists of two sections, which is audio frequency section and radio frequency section. AF section consists of microphone, AF amplifier, and AF power amplifier. AF section of the transmitter generates the modulating wave, that is the signal. The conversion of sound energy into electrical energy is formed by a microphone. The electrical energy that available from the microphone is very low, hence it is amplified through an AF amplifier, and the output from the AF amplifier fed to the AF power amplifier, and it provides the required audio frequency power. Then the output will be given to the modulator. A modulator is an electronic circuit that performs the process of modulation. Next, for the RF section, it consists of crystal oscillator, buffer amplifier, and RF power amplifier. The RF section, the high frequency carrier wave is generated by a crystal control oscillator. The output of the crystal control oscillator is power amplified by RF power amplifier. The buffer then isolates the RF power amplifier from the oscillator. In the modulator, the RF wave and modulating AF signals are mixed to produce the amplitude modulated wave. The output of this section then fed to the antenna of transmission. So, that's all for the amplitude modulation application of radio broadcasting transmission.
So, in summary, amplitude modulation is used in a wide variety of applications such as broadcasting, avionics, and EMC. AM signals are generated by mixing an unmodulated RF carrier with a low frequency modulating signal. Some benefits of modulation are modulation can provide some control over noise or interference. Modulation also permits use of multiplexing. Last but not least, modulation can shift the spectral content of a message signal into a band which is better suited to the channel from low frequency to higher frequency. There are variants of AM signal, and the most common measurement made on AM signal is modulation index, and this can be done using either a spectrum analyzer or an oscilloscope. This concludes our presentation on understanding amplitude modulation. Thanks for watching. Don't forget to hit the like button.